Chaofan, welcome to Validated.
Thanks, Austin. Excited to be here.
Yeah, thanks for coming on today. I want to talk about a bunch of stuff today. One of the main topics being the need for, or the desire for, faster execution environments that are not necessarily exactly L2s in the traditional sense. They're not exactly L1s. They're sort of somewhere in between the space. And I think what you guys are doing with Solayer might fall into that category. So just to sort of set the stage here, what is Solayer? What are you guys building?
We are going to build a sidechain for Solana. It's going to be in between layer 1 and layer 2. And the need for this is that we find out a lot of market makers, especially those that are market makers for perps, they find it very hard to land transactions on Solana, specifically because they need to pay very high priority fee just to open position or close position, which are free on most CEX. And this really hurts the market makers' performance, and also they're wasting a lot of money just to have those positions open. And what we are trying to solve is to have a very large bandwidth chain that is going to be like a side chain for Solana. And a few transactions could be landed on our chain and do the settlement on our chain, but the money is still kept on Solana chain.
Yeah, so we got to do a whole episode on market makers sometime, because this is a whole part of the industry that is very weird and crypto specific. But yeah, so effectively, market makers, they're going out and they're basically trying to make efficient markets and then make some money on that. And in a traditional exchange, they're basically paying one time for access to the exchange. And in crypto, you have to pay every time you send transactions. But Solana transaction fees are famously pretty cheap. So walk me through the economics of something like a market maker and why those, because we think of Solana fees as you put a decimal, you add 3 zeros, and you put a 1 after it. That's pretty cheap. What are the economics and incentives that work in such a way that that this is a market that you guys are looking to serve?
So there are mainly two things that the market maker do. One is that they're creating liquidity, of course, and another thing is that they're handling liquidations. For creating liquidity, they need to send billions of transactions every day just to create all those positions and close the position whenever they see that it's no longer needed or it's going to make them lose money. And although Solana transaction is really, really cheap, but it takes a lot to land that transaction at the desired time. So for example, right now, if you want to land a transaction in a very congested period of time, then you likely need to pay $1 or $2 or even $10 for priority fee just to land your transaction. And most of the time, the market makers are really sensitive to this latency. They couldn't wait 1 or 10 seconds just to open or close their position. They're going to lose money. So they have to pay those priority fee, and sometimes they need to pay millions of dollars every day just to open those positions or close the positions. And another thing for liquidation is that the market makers need to make really, really fast actions whenever they consider a position that need to be liquidated. Otherwise, it's going to create bad debt. And for this, there's on Ethereum they're paying millions, but on Solana they're still paying a lot of money, although not million, but they're still paying a lot of money for that.
Yeah, so I want to the fundamental reason they're paying a lot of money is there's a lot of demand to send transactions at that specific moment. And so there's a lot of folks who have tried to kind of solve these problems by saying oh, we'll just create a new chain, a new market, a new L2, a new whatever. And inevitably what happens is they also just get successful, get a lot of attention, right? Solana fees are higher than they were when there was no one trading on the chain. So how do you think about that balance? And at some point, right, is Solayer aiming to be faster than Solana mainnet? If you're actually successful in pulling a bunch of DeFi activity into your execution environment, how do you prevent the same problem from popping up just now in a different place?
So actually, we're not planning to have the money really on our chain. We're more like a sidechain for Solana. The money stays on Solana, and because a lot of big holders of of Sol or USD, they think that putting their money onto layer 2 or even layer 3 is very risky for them. They don't want to like have their money just ink by those layers. So what we are going to do is to have the liquidity remain on Solana, and our chain is just going to be like a settlement chain for the funds on Solana.
Yeah, walk me through a little bit on like an engineering side. Like how does that actually work? Because we've seen the opposite of this in the Ethereum world. We've seen like on-chain orders, but off-chain order matching, right? Like there's DeFi components where like it's an RFQ system and like you run the RFQ off-chain, but you settle stuff on-chain. Like what's the right mental model to think of what you guys are building?
So it's very similar to RFQ, but everything happens on chain, and we think that it's DeFi, of course, is just one of the use cases of very fast chain or a settlement chain, but there could be a lot more other use cases. For example, like so our chain is basically allowing efficient move of the assets between the chain, between Solana and our chain, and it's like a mapping of the assets that could be settled on our chain, so that every asset on Solana is there, but it could be exchanged or even leveraged or participated in perps or options on our chain.
Yeah. So are you creating like synthetic asset representations? So most of the way the RFQ systems work is they're basically not stateful, right? But they're kind of ephemeral with that regard. But I think what you're talking about here is like a little bit different, and there's a lot more sort of engineering complexity that goes into it. So like, are you like the communication back to the main Solana network? Are people locking funds into escrow contracts? Like if I'm coming to this system once it's built out and I'm saying, oh, I want to access an application or I want to trade on some type of system that's on Solayer, what am I doing as a user?
So the user could just send a transaction on Solana, which include an instruction that bridges to our network, and the funds got put into our escrow contract, and the funds immediately becomes available in the same transaction on our network, and they could add more like backgrounding transactions that are executed on our network, and they could even add a transaction that bridges back to Solana. All of those could happen in a single transaction.
So it's kind of like, maybe this is a bad analogy, but like there are some DeFi applications out there that make you kind of deposit funds into them to trade on them in a similar way to a centralized exchange offers that type of thing. Is that sort of the experience that most users would likely go through? And then at some point they're clicking a withdraw button or something like that?
They won't be clicking a withdraw button. It's more like they can just open position on Solana, and automatically the settlement really happens behind on our chain. The market makers are doing things on our chain, but for the users, they're still on the Solana. They're using their Phantom wallet, and they just need to click sign a transaction, and everything is settled. They don't need to like switch the RPC, like go to our chain and do whatever things. And for withdrawal, they could just make it in the same transaction, or they could just send another transaction on Solana, and the funds would be shoot back.
Yeah. So let's kind of like start at like the lowest level of the stack here. So you guys are building a sidechain. What's it built on? Walk me through the engineering and architecture.
So the chain is built like a fork or fire dancer, but we added a lot more hardware components into it. Specifically, we have hardware for like a fee market, like side fee markets, and we have hardware to handle specific operations like transaction scheduling, and also some transaction execution, and also transaction state sync. So yeah. And for the bridge,
so walk me. Wait, I wanna get a little more into those. Because anytime, like one of the things that originally drew me to Mega ETH was their focus on node specialization, which I think is quite interesting. There's a few networks out there that are doing custom hardware stuff. 00 is doing some FPGA stuff for certain types of accelerated processing. You mentioned sort of you guys have added some hardware. What does that look like, and what's it doing in the network?
So whenever the user sends a transaction, the transaction will first hit an ingress point. And this is like a microservice. It first do the pre-execution, do the scrubbing of the transaction, and do all kinds of pre-processing of the transactions. And then it got sent to our the leader's cluster. The leader has a like a SDN switch, which is going to do on switch planning for that transaction, deciding that whether it should go through a fast pass or slow pass. For the fast pass, it's just directly using the pre-execution result and pushing that result directly to all the other nodes in the network. And for the slow pass, it's going to be sometimes directly executed using FPGA. Sometimes it's going to be executed on the smart NIC, and sometimes it's going to be executed, push it to the CPU for further execution. And after that, we get the new state, and this state also got pushed to all the nodes. So basically, we have a hardware that is ensuring that there could not be dirty read or dirty write, while ensuring the maximum parallelization. And there's also hardware that is accelerating the execution for a specific type of transactions.
And what does this like result for in terms of like performance and experience for someone trading on this system?
So right now we're getting around 1 million TPS for bandwidth, and for latency, it's also getting relatively low. If you place the node right next to the leader, then it's going to be sub-millisecond.
Yeah, so this is kind of like one of the things that I think is really interesting is a lot of approaches that involve high performance are involving specialized hardware, which is like a topic I'm particularly interested in, but then also involves that there's a geographic component, right? I think a lot of people who are not in the space, like they kind of forget that light's actually pretty slow, and light through fiber is even slower, and it actually takes like a meaningful amount of time to go from like one part of the United States to another, let alone one part of the world to another. So yeah, like walk me through a little bit of like how the wider network architecture is set up. Are you kind of running things in a few data centers in a region and then kind of running to the leader wherever it is in the world, or are you kind of building things in a different way?
So there are actually two parts of this. One is that so there has been like a common saying on Twitter, which is that if you're L2 pass your pass the nuclear bomb test. So if I throw a nuclear bomb, will your L2 just be down? But we have a design that is to overcome this, which is that we have like a POA set of sequencers, which could be automatically switched whenever one sequencer is malicious or down. So it's like on most continents, we have our sequencer available, and if one sequencer is down, the network switch to the slow mode. It's going to be like Solana. We go through a full consensus, and whenever until like there is a new sequencer that got elected, and then that sequencer would switch back to fast mode, and that sequencer will be in charge of processing the transactions. And another thing you mentioned about is that like we can't bypass the light speed. So but actually 200 millisecond is pretty much enough for the users. The users do not need to have very fast, very low latency. You can play games with 200 millisecond latency. But actually one thing is that for market maker, they cannot they cannot endure like 200 millisecond. So what we are going to do are two things. One is something we call a hook transaction, which is that on-chain you could specify a transaction that could be directly background all transactions sent to a specific program. So it's automatically happen inside the sequencer. The sequencer would trigger that transaction, and it's going to be like at the same time whenever the transaction is executed. This is particularly useful for liquidation and for arbitrage. And another thing we do is that we're going to have like an auction market space, which is to rent the racks next to our sequencer.
Right.
And the market makers could do the auction and try to win it and get their server just right next to our sequencer and connect it with very short fibers. And it's going to be sub-millisecond.
Yeah, it's interesting. So like the hooks, there's like a bunch of places my head goes with this. So the first is like, at some point, are people basically paying to store transaction instruction sets in state? I'm guessing like, so now this is like a stateful network in that case.
Yeah.
And so like I could basically deploy an instruction set that if a hook calls it, it then executes.
Yes, that is correct.
And because this is traditionally solved through cranks or other types of systems usually. So it's kind of interesting that it's like built in. You mentioned sort of catching the sequencer from a censorship standpoint and moving. It seems like you need a very intrinsic view of what's going on inside the sequencer to catch it. If you now have brought like a traditional, sorry, let me take a step back for the audience. Like in a traditional sequencer model, you have transactions streaming into the device. The sequencer is kind of deciding, but deciding is like a big word for a sequencer. It's mostly just including everything that comes at it because for the most part, it's either doing basic fee market discrimination or there's just not that much demand. And so it's including everything that comes in. And the idea of like censorship resistance there is there's something watching the output to say, hey, my transaction didn't get included. And if it didn't get included, there's a lot of potential resolution mechanisms, the most boring of which is you just submit the transaction to the L1. But sometimes there's like committees or something you can report it to. But the minute the sequencer actually has logic on it and intelligence and is triggering other things to happen, you kind of have like a very different observability problem where you kind of have to replay the entire state to see if a hook would have been triggered, right? So I'm kind of curious how you think about like catching a misbehaving sequencer when it sounds like you guys are asking the sequencer to do a lot more than a sequencer traditionally does.
Right. So like traditional L2, we have a set of provers that could submit fraud proofs. These fraud proofs not only include that the sequencer is just providing incorrect states or doing maliciously, or they could also provide a fraud proof, which is saying that one of the transactions is not included. The user could send a transaction on Solana and force it to be executed on our chain, and the sequencer must execute it in a specific period of time. If it is not executed, then the sequencer will be considered done, and a new sequencer will be elected by the provers.
So like this is my brain's just so in networking world now that like this is my obvious question is like, how do you provide proof or assurance that the transaction actually got to the sequencer? Like it's possible that something was sent on the L1 that says you must include me and the packet was dropped or for whatever reason the data never arrived at the sequencer. Because this is what like there's a lot of these problems when we're dealing with like multiple systems that you don't have to deal with in TradFi, right? In TradFi, everything's in the same data center. You have an A and B feed. Like you've got pretty good assurance that data is always going to move like as expected. But when we're dealing with like, public internet and when we're dealing with sequencers and leaders located in different parts of the world, like how do you deal with the normal variance of just public internet stuff at that scale?
Right. So for like a false push of the transaction on Solana chain to our chain, it's like the Solana is relatively slow, so it's very easy to ensure that the packet gets to our chain, gets to the sequencer. The sequencer will definitely have something like a relayer, which is that it's ensuring the delivery of that transaction to the sequencer, and the sequencer could include the transaction. If it is not included, then the relayer will be retrying until the time limit is exceeded, and the sequencer will be considered down and switched to another sequencer, which is going to try again and see whether the relayer could push the transaction again.
Interesting.
And for normally, like if the user directly send transaction to our network, there is a possibility to have the transaction dropped, unfortunately. But like every network, it's possible. Even for Binance, your like order could be dropped sometimes.
Yes. It's it's kind of funny when you think about like how these systems kind of all fit in. There's just a lot of like networking trust involved in getting these things to work. So as you guys think about like rollout and adoption, like I think the obvious question and maybe like the Kyle Samani question is like L2-ish things can be considered cannibalistic or, totally famously is like, oh, all execution layers are competing with Solana at some point. He considers Binance a competitor. He considers Coinbase a competitor, the NASDAQ, all these types of things. So you guys, I know, made a decision not to necessarily build an L2 and not to build like a full L1. Like, give me kind of the case where this is like a positive thing for Solayer and then also a positive thing for Solana.
So the underlying currency for the like the gas token for the network is SOL, and like the majority part of the chain's consensus or its security is relying on Solana. If the Solana is down, our chain is down. If Solana is back, our chain is back. So it pretty much rely on Solana, and it can ensure that a lot of transactions that are unnecessarily that needs to be sent on Solana could now be sent to our chain and do the settlement on our chain. So like for Deepin project, they don't send all the messages onto the chain because it's expensive, and it's you couldn't guarantee that your transaction always got included. There's only like 10% of the transactions, if underpaid with fee, could be included. So those Deepin project could not do the like all the payment or other stuff on Solana chain, but they could do the high bandwidth message syncing and all those funky stuff onto our chain, so that there could be reduced bandwidth needed for Solana, but actually exploiting like a side channel for communicating.
Yeah, so like the decision to use Sol is kind of interesting as a gas component for the sequencer. What do you expect fees to look like then? And what is the sort of the scalability factor that you think you're able to deliver relative to like the Solana network?
So I'm not exactly sure about the fee, but I think it's going to be similar to the fee that is generated by common validator on Solana for our chain, and those fee will be partly paid to Solana for ensuring that the data is available on Solana, and also ensuring that whenever there is some consensus issue, we could roll back to Solana and do more election related or governance related things. And yeah, for the scaling factor, I think that we're going to be having like around 100 times more bandwidth than Solana. The underlying rationale behind this is that Solana is consisting of a lot of nodes, and right now it's requiring nodes to have 1 Gbps to actually be validating the transactions.
Even with 1 Gbps, it's kind of hard to keep up.
Right.
Yeah.
But for us, we are not going to have all those kinds of syncing things or P2P things. So it's going to be more like a single sequencer that is going to connect it with 1 Tbps fibers, and that sequencer is ensuring the bandwidth, and only like shortcut only thing that could make the chain slow is the sequencer. But for Solana, there could be validators that are just on 100 Mbps network that is making the chain really, really slow.
What is like the ecosystem development timeline and pathway look like?
Right. So right now we're working with a lot of Deepin companies as well. They're really excited about bandwidth and low fee, so they don't have to pay that much fee just to having their IoT device, which is only $10 to send some messages to the users. We're also thinking about gaming. We ourselves are building like a game that is similar to Minecraft. It's going to host all the users in the same world, and the users could build things and destruct things in a global single state. We've been also working with a few other gaming companies.
So the game space is always interesting because it feels like it's perennially like 2 years away from being like a big thing. Like it sounds like you guys are taking a little bit of a bet that Solayer is going to be like a good place for games. What do you think is missing that has made blockchain games not really successful as of yet?
To be honest, the most important thing is that all those big gaming companies, they don't really know about blockchain, and they don't have incentives to use the blockchain, because there's actually nothing that could help them on the blockchain. Yeah. But like if we can have like behave like a server that is going to have a global single state or a global like a key value map, then that is also like very cheap to use, and also very having a very high bandwidth. Then the gaming company will be interested in exploiting this feature and potentially putting their multiplayers architecture onto the chain.
I want to go back to some of the specialized hardware stuff you were talking about. This has been an area that crypto has historically avoided, or they've used it only for like ZK acceleration. Talk to me a little bit about the process of breaking down like a VM stack or, like Turbine and these sorts of components that are in Solana, and trying to identify, like, he said something really interesting to me, which is like some transactions are hardware accelerated. Like, walk me through what that sum is, why it's not all, and like how you guys kind of thought about breaking down some transactions into things that are maybe suitable for hardware acceleration and others that are not.
So there's always a few applications on the chain that are very widely used and used by a lot of people. For example, the perp DAX or Deepin projects. So for those, we are going to translate it to the FPGA logic and directly put it onto the chip, so that whenever those transactions come in, they could directly be processed inside the network device and get the state. And but of course, there are other user transactions and MVV bots that could do funky stuff. So we still need CPU for processing those transactions.
Right. So if you're taking something like a perp stacks or an AMM or an order book or something like that, so implementing the instruction set in FPGA is one thing, but the FPGAs typically don't have a bunch of storage on them, or at least not the type of storage that you need for something like reading the state of a DeFi market. How are you guys thinking through that type of thing?
So SVM is actually stateless. Unlike EVM, you don't know what the transaction is going to access. For SVM, you know what the transaction, like what are the state that the transaction needs.
Yeah.
And before getting into the FPGA, the state is actually coming along with the transactions. And the FPGA is just like providing the new state.
Interesting. Okay, so you effectively need like a terabyte of RAM at the scheduler, so it can supplement the state that's needed in the scheduling phase. So then when it goes for execution in the FPGA, it's got everything it needs. How do you deal with like cascades? So like I do a trade, I move a market, your transaction is right after mine, but now the state that you've injected with the FPGA is stale.
So the scheduler is more like deciding what are the transactions that could be parallelized, and these parallelized are executed on different FPGA with their different disjoint set of states. But for those transactions that are like conflicting, then they're executed one by one.
Or what about transactions that aren't? Well, yeah. So transactions you can't parallelize, does that go through the slow path then? Or because you were talking about like something like a perp stacks, right? And like, right. If you're implementing that in FPGA, like I assume there's outputs that come from that would modify the state that would be important, even if it's within slippage tolerance and everything. Like, how are you closing that data loop back so that then like the next thing coming through the FPGA has the output? Because the thing about FPGAs is, as you know, they're very pipeline based, right? And so like they're not, it's very hard to like have loop backs that take an output from one thing and bring it back to like the front of the FPGA.
Yeah, but actually for FPGA, it's very easy to bring it back to the scheduler, which could be another FPGA based network card. And the scheduler will be in charge. So it's not possible to parallelize the conflicting transaction unless we do speculative execution.
Right.
So of course, for conflicting transaction, we need to execute them one by one.
Yeah, and you mentioned like there's some other type of places you're using like specialized hardware for. Walk me through some of those.
Yeah. So one thing we're using specialized hardware is for turbine architecture.
Mm-hmm.
So we have like we use SDN to broadcast the state from the current leader to a set of replica nodes, which are then pushing the states to the end users. So here we are basically like routing those traffic. So the sequencer itself is not going to produce a UDP packet or TCP packets. It's going to produce like an IP level packets, and then the SDN switch is in charge of reassembling the packet and then creating more traffic and sending it to the underlying replicas.
And where are you guys in the project right now? I know there's kind of the testnet coming up soonish, and then you guys are looking forward to mainnet.
Yeah, so right now we are still like finishing up our hardware parts, but for the software part, it's already fully working, and we also have software simulation for the hardware. And the DevNet right now could already achieve 500,000 TPS with very low latency, purely using software and some kernel level programming. And shortly we'll have the SDN-based routing mechanism and also turbine architecture.
Nice. So if people are interested in sort of learning more, following along in progress, where can they go to learn more about Solayer?
So we tweet, and basically we also have a Discord channel which we routinely push the technical updates, also some community updates. So so all of us believe in building public. So whenever there is some progress, we will tweet it or send it on Discord.
Yeah, let us know how it goes. I think I'm always excited, as I said, about networks that are experimenting with like custom hardware and hardware acceleration. So looking forward to seeing how this progresses in testnet and mainnet launch.
Sounds good. Thanks.